Hi everybody, welcome to Unit 4, Video 5. If you do not have your notes packet out, please go get that. All right, so what we're talking about today are complex fractions. So it says, I can simplify complex fractions. So what you want to do here when you see complex fractions like this is you want to think about them as inside this big set of parentheses right here. And so what you're doing is you're trying to look for a common denominator amongst all the denominators. So between 4, 8, 12, and remember underneath here there's an implied 1. So you're trying to say, what is the common denominator between all of those? So between 4, 8, 1, and 12, the common denominator would be 24. So what you're doing with that, and eventually you're probably going to start doing this in your head, but you're distributing to all of the numerators and then you're simplifying. So I'll write it out the long way, and you're distributing to all the numerators. So it'll look like this. You're saying 24 times 3 over 4 minus 24 times 1 over 8 divided by 2 times 24 over 1 plus 24 times 1 over 12. And then you're simplifying. But like I said, eventually you're going to do some of the simplification in your head, because here 24 divided by 4 is going to leave you with 6. So 6 times 3 gives you 18. 24 divided by 8 here is going to give you 3. So 3 times 1 is 3, so 18 minus 3 over, so on the bottom we have 2 times 24, which is 48. And then we have plus 24 divided by 12, which is 2, times 1, which is just going to give us 2. So then when we go ahead and simplify here, we have 18 minus 3, which is going to give us 15. On the denominator, we have 48 plus 2, which is going to give us 50. But remember, you always want to make sure it's fully simplified. So I can divide both of these by 5. So when I divide both of them by 5, I'm left with 3 over 10. So this is my final answer. So again, you're looking for the common denominator, you're multiplying it to all the numerators, and then you're simplifying. Okay, so let's go ahead and look at number 2. So again, you're saying between all of them. So 1, x, x squared, 1, and x. You're saying, what is the common denominator? Well, the common denominator would be x squared. Don't say x. X would be a common factor, but you want the lowest that they can all multiply to. So x can multiply to x squared. So again, you're multiplying them to all the numerators. This is the whole number because the numerator is 1. So you're just going to multiply it. So you have x squared. Again, you can think about it the long way if you want, but eventually you can take a shortcut. So you're saying all the numerators here. So 3x squared over x plus 2x squared over x squared divided by, again, this is going to everything inside the parentheses. So you're saying x squared plus 2x squared over x. And then you're reducing. So here I have x squared. This middle term, x squared and x are going to cancel to 3x. Here I have 2x squared over x squared. That's going to cancel, so plus 2. On the bottom, I have x squared. And then here, these are going to reduce to plus 2x. Now remember, these are expressions. They're bounded by parentheses. There's an invisible parentheses around them. So you can't just cross out these x squareds. This is a trinomial, this is a binomial. So if possible, you need to factor. And this top one is factorable. The factors of 2 that add to 3. So we're going to say x plus 2 times x plus 1. In the denominator, same thing. You want to say, is there anything you can factor? And yeah, you can factor out a GCF of x. And when you do that, you're left with x plus 2. So now that it's fully factored, now you can simplify. So this x plus 2 on the top is going to cancel out with the x plus 2 on the bottom. Remember, this x plus 1 is in parentheses, so it stays. So it's x plus 1 over x. Again, you cannot cross out these x's because this one is in a parentheses. All right, so let's go ahead and go to number 3. So same thing applies when you're looking for the common denominator of an expression, but just remember, these are in a parentheses. So if you think of the whole thing, you're saying, what is the common denominator between 1, k minus 2, and 1? Well, the common denominator would be k minus 2. So again, the only difference is that it's an expression, but the same rule applies. We're applying it to all the numerators and we're simplifying. So here you'd have k parentheses k minus 2 plus k minus 2 times 1 is k minus 2 over k minus 2 divided by, here I have k squared parentheses k minus 2 over k minus 2 plus 1 times k minus 2. All right, so now you can go ahead and reduce if possible or distribute. In this case, we have to distribute. So we have k squared minus 2k. On this next one, yes, they'd cancel out, but remember, if something on the bottom is the same as something on the top, this turns into a 1, not 0. It doesn't just disappear, so it's plus 1. On the bottom here, k minus 2 cancel, so you're left with just k squared. And here, when you distribute the 1, you have plus k minus 2. So again, these are trinomials, so you need to factor them if possible. So the factors of 1 that add to negative 2, this is going to factor into k minus 1 times k minus 1. On the bottom, the trinomial, k squared plus k minus 2 is going to factor into k plus 2 times k minus 1. So then, when you simplify, one of the k minus 1's in the numerator can cancel out with 1 in the denominator. So your final answer here is k minus 1 over k plus 2. All right, so before we can simplify or do anything, you have to make sure you have only positive exponents. And so you need to be careful with this one. You're not flipping the whole thing of the fraction to the denominator because it's already in the numerator by itself. So you have to flip this one. So here, you're going to say it's 1 over r to the third plus 1 over x to the third divided by 1 over r plus 1 over x. So now that you have all positive exponents, now you can look at each of the denominators and decide what is the common denominator. Well, in this case, the common denominator is going to be x cubed r cubed, because again, not the common factor, the common denominator, the lowest number they can multiply to. So again, you're distributing it to all of the numerators and then simplifying. So I have x to the third, r to the third, over r to the third, plus x to the third, r to the third, over x to the third, divided by x cubed, r cubed, over r, plus x cubed, r cubed, over x. So then we can go ahead and simplify. So when we simplify here, r cubed is going to cancel out, so you're left with x cubed. In the numerator here, the numerator and the denominator, you have x cubed, so those can cancel out, so you're left with plus r cubed. On this one, the r cubed and r to the first can cancel, so you're left with x to the third r squared, plus this one, the x cubed and the x can cancel, so you're left with x squared r cubed. All right, so now you have to factor if possible. And so you have to think back to the last unit. This is a special case. X cubed plus r cubed is a sum of cubes. So it is factorable. So when you factor this sum of cubes, it's going to factor into x plus r, and then it's going to leave us with the trinomial. X squared minus xr plus r squared. So again, you had to go back to last unit and hopefully you memorized those special cases here. So again, this is a sum of cubes. On the bottom, you have to say, is there anything that you can factor out of them? And you can. They have a GCF of x squared r squared. So you're going to factor out the x squared r squared. So when you factor that out here, you're left with x. From the second term, when you factor that out, you're left with plus r. So now if you notice, x plus r on the top can cancel out with x plus r on the bottom. So your final answer, this can't factor anymore. So you're left with x squared minus xr plus r squared over x squared r squared. So x squared r squared. So this whole thing is your final answer. Okay, so I want you to go ahead and pause the video and try to do number 5. Okay, so hopefully you've gotten to this point right here where you have y squared minus x squared. On the bottom, you were able to factor out the xy, so you have x squared plus y squared plus 2xy. So now remember, you always want to make sure things are fully simplified. And in this case, this trinomial, we can rearrange it so that we can factor it. So I'm going to go ahead and do that right here. So on the numerator, I'm going to keep it as y minus x, y plus x. In the denominator, I have xy, and then I'm going to reorder this to be I'm going to reorder it to be y squared plus 2xy plus x squared. Okay, and the reason that I put the y squared is because in the numerator, the y was first. So when I factor, so again, I'm just going to rewrite my numerator like this. Then on the bottom, I factored out xy. And so now when I factor this, this is a perfect square trinomial. So this is going to factor into y plus x times y plus x. So once you get to this point, you can go ahead and simplify. All right, so the y plus x on top cancels out with the y plus x on the bottom. So then you have parentheses y minus x over xy parentheses y plus x. So this whole thing is your answer. So again, you always want to look and see if there's something you can rearrange or you can do so that you can factor or fully simplify. Because remember, everything has to be simplified completely. All right, so let's go ahead and go to number 6. And remember, with number 6, before you can do anything, this negative exponent needs to turn positive. So you want to think of it as 1 over x plus y over x plus 1 over the quantity xy. Remember, it's to the first here. So I want you to go ahead and pause the video and you try to do this one. Okay, so let's go ahead and see how you did. So hopefully we all got to this point where we have y plus xy squared over y squared plus 1. Well, on the numerator, there's one more step that I could do, and I can go ahead and factor out the GCF here of y. So when I do that, I have y parentheses 1 plus xy. And in the denominator, y squared plus 1 doesn't simplify. So I'm just going to rewrite it as y squared plus 1. So this whole thing is my answer. And the reason you wanted to factor out this GCF is because you always want everything fully simplified. So here is your final answer. All right, everybody, thank you for watching the video.